higher order Galois field. So question is, there is a question: construct the Galois field of g of t to the power 4 whose modulo polynomial is given by x to the power 4 plus x plus 1. Determine the minimal polynomial for the elements only for alpha 5 and alpha cube for above case. Now we have to construct the Galois field of gf of 2 to the power 4, that is the order of extension is 4, that is the constructed field will have 4 bits of 4 elements in one symbol, and one element will consist of 4 bits or 4 digits of gf of 2, 4 digits of gf of 2, so either 0 or 1. So there will be 4 digit combination of gf of 2. So we can first represent the higher order extension field in 3 ways. That is for one of the method is 4 tuple, this is n tuple representation, which we are studying in digital circuit and digital communication. This is 0 0 0 1 and so on. So in the form of digit gf of 2 elements. Okay? Or you can also represent in polynomial form and power form. Okay? So in all of these 3 representation we will show the Galois field. So now consider now what is given, that is modulo polynomial is, that is it is nothing but the it is our irreducible polynomial, which is the minimal polynomial. Okay? It is our so it is our primitive polynomial. Okay? Another name is modulo polynomial. Polynomial is another name for primitive polynomial. So from this given primitive polynomial we will construct the higher order extended field, because that is when we have to construct of 4th extension we will need the degree 4 polynomial, degree 4 primitive polynomial. Okay? For that is if it is gf of 2 cube, we will need the degree 3. So if it is not given, that is the modulo polynomial is not given, so then you have to remember that is x to the power 4 plus x plus 1. You have to remember this. Okay? So because there is one of the polynomial of irreducible polynomial, which is the primitive polynomial. So from primitive polynomial we will construct the Galois field. Now consider p of x. P of x our primitive polynomial, so which is x to the power 4 plus x plus 1. So it is the irreducible polynomial, so it doesn't have root as 0 and 1. So it will have the roots of gf of 2 to the power 4. Gf of 2 to the power 4. It will have the roots of gf of 2 to the power 4. So let that root be alpha. Okay? Let it is alpha. So alpha be the root of gf of 2 this polynomial, and it is the element of gf of 2 to the power 4. It is also the element alpha is the element of gf of 2 to the power 4, and we have considered, or it is the root of primitive polynomial p of x is equals to x to the power 4 plus x plus 1. So if it is a root, so p of alpha will be 0, that is alpha to the power 4 plus alpha plus 1 is equals to 0. So we have the equation alpha to the power 4 is equals to alpha 1 plus alpha. So for the gf of 2 to the power 4, highest degree of alpha is 3. Okay? So when it is greater than 3, we will convert into maximum of 3, maximum of degree 3 of p of alpha. So now it is the representation in the polynomial form, that is we have represented alpha to the power 4 in polynomial representation. Similarly we can represent each of the element in polynomial form. Similarly the third representation, which is the power representation, we can also represent, that is it is our power representation. So it is very simple, 0 1, smallest element will be 0. Okay? It is the power representation, that is alpha to the power infinity. If I say alpha to the power infinity, so it will alpha to the power minus infinity, it will be 0. Okay? Similarly alpha to the power 0 is 1, alpha to the power 1 is alpha square, alpha cube, and so on till the total number of possible elements. So there will be total 16 possible elements. So alpha 14 will be the largest element of gf of 2 to the power 4, and it is this first column shows the power representation. ठीक है. Now we can convert the power representation into polynomial form. So for the polynomial form, highest degree of alpha